Today's lesson 3.1, constant rate of change. Remember to copy your work on a separate sheet of paper. What we will learn today. To determine if a relationship is linear, find the constant rate of change in a linear relationship, and determine if a relationship is proportional. So these are the three things you should know by the end of this lesson. A couple of vocabulary words that apply to this lesson. The first one is linear relationships. These are relationships that form a straight line in a graph. So in other words, if we were to graph these relationships, they would form a straight line. The second word is constant rate of change. The rate of change between any 2 points in a linear relationship is the same, which means it's constant. So we have this example here, this table with number of songs, which is represented by Y, and time in minutes, which is represented by X. And as you can see, as the number of songs increases from 0 to 2 to 4 to 6 to 8, the number of songs is being increased by 2 every single step. And the time is being increased by 1. We would write this into a fraction of Y over X. And our Y, the rate of change, or the change in Y, is plus 2. And the rate of change in minutes is plus 1, or 2 over 1. Okay. So in other words, for every 1 minute, there are 2 songs. Part-time job. The amount of money that Rodrigo earns is shown for different numbers of hours worked. Is the relationship between the amount earned and the hours worked linear? So in other words, if we were to graph this, would it become a straight line? We don't want to be graphing yet. There's no need to graph. We can find if it's linear without graphing. If so, find the constant rate of change. And if it's not linear, explain your reasoning. So to find out if, excuse me, if a relationship is linear, let's look at our 2 columns. We have our number of hours column, which is our X column. In our Y column, which is the amount earned. So the Rodrigo, for working 5 hours, is going to make $70. For 10 hours, 140, and so on. We're noticing that the hours are changing by 5. So the increase in hours is by 5. And at the same time, the amount earned is being increased by 70. From 70 to 140 plus 70. From 140 to 210 plus 70. 210 to 280 plus 70. You can always do the reverse too, subtraction. It's still going to give you the same rate. So because our changes are the same, plus 5, plus 5, plus 5 on the number of hours, and the plus 70, plus 7, plus 70 in the amount earned, yes, this is linear. Okay. That's the first part of this problem. The second thing they asked us is to find the constant rate of change. And now because it is linear, we can find the constant rate of change. And to find the constant rate of change, we are going to take my Y, which is the change in the amount earned, divided by the number of hours, which is X. So Y is going to be the change in amount earned, which is 70, divided by 5. The 5 represents the number of hours. 70 divided by 5 is 14. So my rate of change, so this is telling me that the rate of change is $14 per hour. So the Rodrigo is making $14 per hour. That's our constant rate of change. Let's look at another example. Determine the relationship between the two quantities shown in each table or graph is linear. If so, find the constant rate of change. If not, explain your reasoning. So again, first we need to determine whether the relationship is linear. And if it's linear, we're looking at to see if they have the same amount in change. So if in time, adding 1, from 1 to 2, 2 to 3, 3 to 4, looks like it's that part so far is linear, but we need to check both parts. We also need to check the distance. That's very important also. So for this one, I need to look at the change between 19.6 and 4.9, which is adding 14.7. And then I need to look at the change from 19.6 to 44.1. And what I'm doing is I'm subtracting. I'm using my calculator to subtract. And that's actually 24.5. And you might say, Mr. C, but why are you subtraction when you're adding? What I'm doing is I'm taking, to find the difference, or to change from 4.9 to 19.6, I took 19.6 minus 4.9, which gave me 14.7. So from 4.9 to 19.6, it's going up 14.7. Okay. So right here, because these are different, this is not linear. So my answer would be not linear. Why? Because the reason, so it says, if not, explain your reasoning. Not linear because the change in distance over time, and in this case over 2 minutes from 1 to 2 to 3, is not constant. Again, because we have to explain why it is not linear. We don't just write not linear, you have to explain why it's not linear. So there's my answer. Let's look at an example with a graph. First, we want to see, is it linear? And if yes, get the constant rate of change. If no, why not? Okay. So with the graph, it's actually pretty easy to tell if this is a linear relationship or not. Because I can see that if I were to join these lines together, it looks like it's going to form a straight line. So that's pretty obvious. So we can say, yes, it's linear. Okay. Our next step, so now that we know it's yes, we want to find the constant rate. And to find the constant rate, we're going to have to look at look at the points. So I see that it starts at 0, 0, so I can make myself a table if I want to. So I can have a table. We'll say this is the water level. And I got water level from there. And then we'll say time. And there's 4 different points. So for the time of 0, the water level is 0. And it looks like it's, well, it is going up by 2's in time and 2's in water level. So time is, if it goes up, we're looking at between 2 and 0 is obviously 1. It's going to be 2. At 2 minutes, water level is 4. At 3 minutes, water level is 6. We already know it's a linear relationship, but let's look at it. We're increasing by 1 in the time, and we're increasing by 2 in the water level. So we know that the water level is going up by 2, the time is going up by 1. Okay. So my water level, you can see, is Y. So my Y, my change in water level, is going to be 2. My time is X. That's my numerator. And my time is going to be 1. So the constant rate is 2, and we know it's inches, 2 inches per minute. So for the first part of this lesson, we were looking to see if we had linear relationships, and then we were finding the constant rate of change. Now we're going to take it a step further. We're going to look for proportional linear relationships. And in words, what this means is two quantities, A and B, have a proportional linear relationship if they have a constant ratio and a constant rate of change. So in symbols, A over B is constant, and the change in B and the change in A is also constant. Our next example, we are going to determine whether a proportional relationship exists between the two quantities shown in the following exercises. Explain your reasoning. So again, here we're going to we're going to put each of these individual quantities into ratios or fractions. And if they all equal the same, then it's proportional. So this is going to be my X, my time is going to be my X, my cost is my Y. We're still going to do Y over X. So for the time of 5, my cost is 15, or it's $3 per hour. Let's look at the next one. 24 over 8, once again, $3. So far, it looks like it's proportional, but let's keep going. 36 over 12, 36 cents over 12. Actually, it should be cents, so not dollars. Sorry, I just noticed that. 3 cents. Let me go back and change that. 3 cents, 3 cents, and 3 cents. And finally, 72 over 24, once again, 3 cents. So the ratio resulted in 3 cents for all 4 different relationships. So determine whether a proportional relationship exists between the two. Yes. Explain your reasoning. The costs are all, I wrote dollars again, 3 cents.